Mangaru's Tutoring Services, Mathematics Classes. SEA Maths Revision 1. This Revision 1 is geared towards covering the majority of the SEA Maths syllabus type questions. Before you look at the solution, please access the question paper and attempt all of the questions. Let's begin correcting. Number 1. Words as numerals, 65,051. B. Numerals as words, 308,207. Number 2. Expanded notation, 1 by 1,000, 9 by 100, 2 by 10, and 4 by 1. B. 7 times 100,000, 5 times 10,000, 6 times 1,000, 3 times 100, 5 times 10, and 8 times 1. 3 times 100,000, we can leave the 0 out if we like, or we can add it in as 0 times 10,000. 8 times 1,000, 2 times 100, 0 times 10, which can be included or excluded, and 7 times 1. Number 3, rounding off. Rounding off 541 to the nearest hundreds. So this is a hundreds number. The number, or digit rather, to the right of it is less than 5. So we will not add 1 to the hundreds number, so it remains as 5. We change the digits on the right of it to zeros, so the answer is 500. Or in other words, we are asking ourselves, is 541 closer to 500, or is it closer to 600? And since it's less than 550, it's closer to 500. B. Round this off to the nearest hundreds of thousands. So we identify the hundreds of thousands digit. The 9 is 5 or more, so we are going to add 1 to the hundreds of thousands number. So that makes it 2 plus 1 is 3. And we changed all the digits on the right to zeros. So that's 300,000. Next, round off this number to the nearest tens of thousands. So we don't have any number in the tens of thousands position. So we will put a 0 here as a placeholder. We check the digit on the right, it's 9, so it's more than. So we will add 1 to the 0, so that makes it 10,000. Next, round this off to the nearest 1. So this is the ones digit. The 7 is greater than 4, or some places say 5 or more. So we will add 1 to the 6, which makes it 7. So the answer is 7, or you can put 7.0 to replace the 7 on top here. 4. State the value of the underlying digit. So the 3 is worth 300 because it's in the hundreds position. The 0, all zeros have a value of 0. And the 6 is in the tens position. So that's 6 tenths, or 0.6. State the place value of the underlined digit. So place value means which position or column the digit is in. So the 2 is in the tens position, the 0 in the ones position, and the 7 in the tenths position. Next, circle the prime numbers. So prime numbers only have two factors, 1 and the number itself. So we can see the prime numbers here. Of course, you can check through all of them and then identify which ones are prime. Next, we have composite numbers. Composite numbers have more than two factors. So if we check each digit, we will realize that these three numbers are composite. Number 6, ascending order. So we are going from the smallest to the biggest number. So this one is easy. We can see the answer here. B, we have fractions. What we can do is we can find the LCM. So the lowest common multiple of 4, 3, and 2. That will be 12. 4 can go into 12, 3 can go into 12, and 2 can go into 12. So we say 4 into 12 is 3. 1 times 3 is 3. We say 3 into 12 is 4. 1 times 4 is 4. And 2 into 12 is 6. 1 times 6 is 6. Right? So we can see the order. It's actually right. So we can see the order here. 1/4, 1/3, and 1/2. Another way we can work this out or think of this is that if we have the same numerator and we have different denominators, then we can put it in the order of biggest denominator to smallest denominator. C. We have fraction, decimal, and percentage. So what we can do is we can convert all of the different items to the same unit or the same form. So we can either change all to fractions, all to percentage, or all to decimal. So I think it might be easy to change them to percentage. So how do we change 1/5 to percent? Well, we say 1/5 times 100. So that's 5 into 5 is 1. 5 into 100 is 20. So that's 20%. Point 3, we multiply that by 100. So it means to shift the point 2 places to the right. So that will give us 30%. 1 means 100%. If we multiply it by 100, we will get 100%. So we can see the order here. 1/5 will go first, followed by 25%, followed by 0.3, followed by 1. Next, using all three digits 1, 4, and 2, make a number that is divisible by 4. So we can do this the long way and try the 3 digits. We can write down 1, 4, and 2 and divide it by 4. Or we can try 1, 2, and 4 divided by 4. 4, 2, 1 divided by 4. We can try all of the numbers. Or we can use the rule, one of the rules with divisibility, and we can say once the last digit or last 2 digits is divisible by 4, then the entire number is divisible by 4. So since this is divisible by 4 and this is divisible by 4, then the number is divisible by 4. So whether it be 412, 124, what else will work? Well, I think that's it. Oh, so it's the last 2 digits. Yes, it's the last 2 digits, not the last digit. So the last 2 digits must be divisible by 4. Okay. So B. using the 3 digits, make the smallest number that is divisible by 3. So we want to firstly try the smallest number first, followed by the next smallest number. So 1, 2, 3, we could try dividing that by 3, right? One of the rules with divisibility is if we add the numbers, or we add each digit rather, in this case we get 6, and we divide it by 3, then it means that the number is divisible by 3. So in this case, if we put a number 1, 2, 3, or 3, 2, 1, or 3, 1, 2, we will always get a number that is divisible by 3. So let me just double check that to make sure it's correct. Yeah, it's working out fine. Right, you can leave a comment in the chat if it is that you have something different. Okay, so part C. Let me just get some water in the meantime. Form the smallest number using all 4 digits. Right, so this one is similar to B but easier. So that's it, 4, 5, 7, 9. Easy. Next we have multiplication. I'm going to assume that you all can multiply at this stage. Right, so you should get 632. So let's go through the division. 6 into 2, I want you all to put that 0 here. Right, remember that. And then 6 into 20 is 3. 3 times 6 is 18. And then we have, right, so we minus here, we bring down the 4, and we have 24. 6 into 24, 4. And then if we have a 0 at the end, we say 6 into 0 is 0. Or some persons say we put back the 0 at the end. C. We know 9 squared is 81, and we know that the square root of 121 is 11. So when we add this together, we get 92. 9a. 1/3 is equal or equivalent to some numerator over 9. So we multiply 3 by 3 to get 9. So we must multiply 1 by 3 to get 3. So 1/3 is equal to 3 9ths. 3/4 equal to 12 over what? Well, 3 times 4 is equal to 12. So we do the same for the denominator. 4 times 4 is equal to 16. C. 1 plus 2 is 3. And if we add 1/4 and 2/3, we'll get 11/12. Right? If we use the denominator of 12, LCM of 12, we can say 4 into 12 is 3. 3 times 1 is 3. And then we can say 3 into 12 is 4. 4 2s are 8. So 3 plus 8 is 11. Next we have 3 minus 1 is 2. So that will leave us with 2 and 1/5 minus 1/3. But 1/5 cannot take away 1/3. We can use a denominator of 15. Right, if the numbers are small, you can even say 5 times 3. You can multiply the denominators. 5 times 3 is 15. Then we say 5 into 15 is 3. 1 times 3 is 3. Take away 3 into 15 is 5. 1 times 5 is 5. So we can see here clearly that 3 cannot take away 5. So we borrow 1 from the 2, and we are bringing this across as the denominator. The denominator is 15. So 15 plus 3 is 18. 18 minus 5 is 13. So the answer is 1 and 13 over 15. Alright, don't forget your 1 from here. Next, easy, we have some geometry type questions here. This is a perpendicular line, as can be indicated by the small square for the angle. Horizontal line is going across. Vertical line. Parallel lines. These lines go in the same direction. They maintain the same distance apart. And they never meet. Circle the angles which are more than a right angle. So we have an obtuse angle here, a reflex angle here, a reflex angle here. All of these are more than a right angle. Next, how many quarter turns to get from A to B? So that's 1. So that's 1 right here. We're not counting the one at B because we didn't pass that corner point at B. And then how many quarter turns from B to C? So that's 1, 2, 3. Right? 1, 2, 3. How many quarter turns from east to north in a clockwise direction? So clockwise is this way, the direction the hands of the clock move, and anti-clockwise will be in the opposite direction. So from east to north, that will be 1, 2, 3. 1, 1, 2, 3. B. How many quarter turns from south to west in an anti-clockwise direction? So that would be 1, 2, 3. 1, 1, 2, 3. C. 5 quarter turns were made in a clockwise direction and ended up at north. Where did we start? So we're going back to where we started, so we're going in the opposite direction. We're making 5 quarter turns in an anti-clockwise direction. So that's 1, 2, 3, 4, 5. So we ended up on west. Complete the description of the quadrilaterals. So here we have completed a table. You can feel free to go to our quadrilateral video to further understand all of the properties seen here. So a square has 4 lines of symmetry, 2 pairs of parallel sides. A parallelogram has 0 lines of symmetry and 0 right angles. A trapezium have 1 pair of parallel sides. A rhombus has 2 lines of symmetry, 2 pairs of parallel sides, and no right angles. Next, solids. So I won't go through each item. So take a look and make your corrections. Now remember, we have a full video on solids where we have 3D printed the shapes and we go through all the faces, edges, and vertices. We even have a video on cross-section of solids. You can take a look at that as well. Right, circle the following shapes which have a uniform cross-section. So that's a cuboid, the triangular prism, and the cylinder. State the name of each triangle. 2 sides and 2 angles are equal. That's an isosceles triangle. All the sides and all the angles are different. That's scalene. And all the sides and all the angles are equal. That's equilateral. State the name of the polygons given the number of sides. So 8 sides octagon, 6 sides hexagon, 7 sides septagon or heptagon, and 5 sides pentagon. Here we have a question based on the distributive law. So basically what they are doing here is we have one number times another number, and then we have two multiplications with an addition sign between them. So what this type of question does is it breaks one of the numbers into two parts. So we see 17 here is broken into 10 and 7, and the other number remains the same. So we're seeing 9 and 9. Right? So we just have to check 17 is equal to what? 10 plus 7. Similarly, we are seeing one number staying the same, 8, 8, and then the other two numbers, 14 and 7, makes 21. So that means the 8 remain the same. And then we have a different question here now. 2 times what plus 7 is 23. So we know 2 times 8, if we try numbers, we can say 2 times 8 is 16. 16 plus 7 is 23. Or we can say 23 take away 7 will give us 16. And then 16 divided by 2 is equal to 8. So basically we worked backwards to get the 8, or the missing number. D. Find the midpoint of the line AC. How I normally explain this is I said, well, okay, if we have a number here, let's say we had a number 7 and we have a number 9. How do we get a number in the middle? Well, we know that it's 8 because that's easy, right? But if we didn't know, if it was more complex, we would say 7 plus 9 is equal to 16, and then we can find half of 16, which is the same as 16 divided by 2, and that will give us 8. So we will use the same approach for this. We're going to add the fractions, and then we are going to multiply it by half. So that's all you need to do. 2 8s plus 10 8s, right? 5 over 4 is equivalent to 10 over 8. And we get 12 over 8, and then we multiply that by half, and we get 3/4. 18. Draw the lines of symmetry for each shape. So a circle has an infinite number of lines of symmetry. Regular polygons have the same number of sides as the number of lines of symmetry. So this is a pentagon that has 5 sides. So there are 5 lines of symmetry. A parallelogram has no lines of symmetry. Complete a shape given that x, y, and AB are lines of symmetry. So if we use x, y as a line of symmetry, then this would reflect here, and this would reflect here. So this is actually missing something. So let's fill it in. Right, so this line will reflect here, and this will reflect here, and then this entire piece on top here will reflect below this line. So this will come down here, this will reflect here, this piece here, when we fold it, it will come here, and this piece, when we fold it, it will come here. Patterns. Putting the missing term or terms for each pattern. So here we have squared numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Next we have these triangular patterns. Right, so we can see that we are starting with 1 on top, then we are increasing by 1, 1 plus 1 is 2, then we are increasing by 1, 2 plus 1 is 3, so each row below has 1 more. So this is supposed to be easy. Then C, what do we have here? We have the number increasing, then decreasing, increasing, then decreasing. 0 plus 5 will give us 5. 5 minus 1 will give us 4. 4 plus 5 will give us 9. And 9 minus 1 will give us 8. So we see the pattern. Plus 5 minus 1. So 8 plus 5 is 13. 13 minus 1 is 12. So we have a pattern with a cardinal point. So let's make a sketch. So we have north, they give us north first, then west, then south, then east, so we are going in an anti-clockwise direction, making quarter turns. So the next one will be north, then west. So what do we have here? Letters of the alphabet. A, skip B, we have C, skip D, we have E, skip F, we have G, skip H, we have I, skip J, we have K. Then lastly, we have cubed numbers. So 1 cubed, which means 1 times 1 times 1 will give us 1. Then we have 2 cubed, which gives us 8. 2 times 2 is 4, 4 times 2 is 8. Then we have 3 cubed is 27. 4 cubed is 64. And 5 cubed is 125. So at least learn your first 6 cube numbers. Next, we have another pattern. Let's see, 10 plus 1 is 11. 11 plus 2 is 13. 13 plus 3 is 16. 16 plus 4 is 20. 20 plus 5 and 25 plus 6 is 31. So let me give you all a little time to take down these corrections. I realize I didn't give you enough time. Right. So let's look at 21. We have these 4 shapes making the core pattern, right? So this pattern will repeat over and over and over in the same order, right? So 50 cards. So we are looking for the 50th card. Now, I don't recommend that we count all the cards. We don't say, well, this is 1, 2, 3, 4, 5, 6, 7, 8. No. That will take too much time. Instead, what we can do is count how many shapes in the core pattern, which we can see it's 4, divide the nth term, which is the 50th term, by 4. So 4 into 50 is 12, because 4 times 12 is 48. And we get a remainder of 2. And what is important is the remainder. The remainder is key. So we come from the start and we say 1, 2. And this is the 50th card. Next, a pattern is formed using sticks and rubber balls as joints, as seen below. If 6 triangles are formed, how many sticks were used? So I am hoping that the questions that I gave you all, you all would be able to make a sketch. Because if it's way too advanced, it means that you would have to create a formula. And I don't think that that's part of the syllabus. So let's go based on completing the shape and counting. If 6 triangles are formed, so we were given 1, 2, 3, 4. So we draw the next 2, 5, 6. how many sticks, so we count all the sticks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And B, if 10 rubber ball joints, meaning the corners, were used, then how many triangles were used? So we draw until we get 10 corners. So that's one corner. Let's count the joints. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8 triangles. 23. Billy was 5 years old in 2003. Ali is 2 years older than her brother Billy. In what year was Ali born? So one thing we know is that Ali would be born 2 years before Billy, since she's 2 years older than Billy. So let's determine what year Billy was born in. So Billy's date of birth, or year of birth rather, would be, well, let's look at this information that they gave us. They said he was 5 years old in 2003. So once we have someone's age in a particular year, we can find their year of birth by subtracting. 2003 minus 5 will give us 1998. And Ali was born 2 years earlier, so that's 1996. Next, Camille, their mom, will be the sum of their ages in 2022. In what year was Camille born? Alright, so let's find Billy and Ali's age in 2022 and add it together, and that will give us their mom's age, and then we can find their mom's date of birth. So Billy would be 2022, take away his year of birth, will give us 24 years. Ali is 2 years older, so we just add 2. 24 plus 26 is 50. So their mom is 50 years in 2022. So remember I said that we can just subtract someone's age in a particular year to find their year of birth. Right, so we have some questions missing. Don't worry about that. I accidentally numbered the questions wrong. So after 23, we have 27. Calculate the average of each set of numbers. So to find the average of a set of numbers, we add the numbers and then divide by the amount of numbers. So that's 48 divided by 4 is 12. Similarly, we get 9 and 22. Number 28. West Indies scored an average of 250 runs in their last 2 matches. What is their total? So if we are given the average for our set of numbers, we can multiply the average by the amount of numbers to find the total. 29. Esther wrote her first 3 out of 4 subjects and obtained an average of 73%. She needs an average of 75% or more to get a grade A, or an A grade. What is the least she can score in her last exam? So the best approach for this will be to determine her total for the 3 subjects and then find the total needed for the 4 subjects and then subtract the total for the 4 subjects, the total of the 3 subjects from the total of the 4 subjects. So let's look at that. They gave us a total, the average, for the 3 subjects. That gives a total of 219. She wants a 75% average for the 4 subjects. So that gives us a total of 300. 75 by 4. So the difference would be 300 is needed. She have 219. So she needs 81 in her 4th subject. 81%. Number 31. So we have 4 numbers, 1 missing. X has the same average, that should be X and Y, sorry. X and Y have the same average as A and B. Determine the value of A. So let's firstly find the average of X and Y. 15 plus 17 is 32. 32 divided by 2 is 16. So A and B would also have the same average as X and Y. So if two numbers have a particular average that is the same as another pair of numbers, then their total will also be the same. So A plus B is 32, we have B as 10, so we subtract 10 from 32 and we'll get A. Number 31. How many 5-cent coins are there in $6.40? So what we can do is we can convert $6.40 to cents only by shifting the point 2 places to the right. So that gives us 640 cents divided by 5 cents. When we divide, we get 128 5-cent coins. 32. Find the sum of the money. So let's add the dollar notes. 150, 170, 190, 210, 15, 16. That's $216. And the coins, 25, 50, 60, 70, 80, 90. So that's $216.90. 33. What is the least amount of dollar notes that would sum to $186? So we use the biggest dollar notes that we can use before going to the next or the smaller dollar note. So we have 100 plus 50, that's 150, 170, 180, 185, 186. So that's 6 dollar notes that we are using, or 6 bills or $6 notes. Similarly, 34 asks us, what is the least number of coins that would sum to 40 cents? So the biggest coin that we have is a 25 cents coin. If we use two 25-cent coins, we'll end up with 50 cents. That's too high. So 25 plus 10 is 35, plus 5 is 40. So that's 3 coins. 35, we have a best buy question. So we have something missing here. We have 5 for 550. Store B. Okay, so we have best buy. So what we want to do is find the price for the same quantity of items for each stall. So right now we have 6 mangoes here and 5 mangoes here, so we cannot properly compare the prices. So what most persons do is they find the price of 1 mango here and 1 mango here and compare, and whichever one is cheaper or lower, that is the better buy. So the lower unit price, meaning the price of one item. So here we have 6 mangoes for $6, so we divide and we'll get $1.05. I store A. And then here we have 5 mangoes for $5.50, so we divide and we get $1.10. So stall B is cheaper by 5 cents. Number 36, complete the table. So $10 per kg or $10 for 1 kg. So 3 kgs will be 3 times 10 is 30. $3 for an orange, 5 oranges will be $15. $20 per kg. 2 kgs would be 20 times 2 is 40. We add all of these together and we'll get 85. Number 37, we have profit and loss. So 36 is the cost price. He sold each piece for $5 and it's a dozen pieces. So 12 times 5 is 60, so the selling price is 60. The cost price is 36. So since the selling price is higher than the cost price, he made a profit. The profit is selling price take away cost price, which is $24. 38. A box containing a dozen glue sticks. Okay, so we multiply the selling price for one of the items by 12, so we'll get a total of $115. Is that correct? 15? No, something is wrong. That's supposed to be $15. So there's a typo here. Right, we know that the profit is $3. Right, so it means that the profit is $3 more than the cost price. So if we take away the $3, we'll get a cost price. Or in other words, the cost price is equal to selling price minus profit. 15 minus 3 is 12. Number 39, we have a discount of 15%. So we can find 15% of 400, which is 60. We subtract the discount to find the discounted price or the sale price, and that will give us $340. Now Tanya bought a combination of these items, so a certain amount of red mangoes, a certain amount of tortillas, and a particular amount of toffees. We need to determine what exact numbers for each item that will total $17.75. So one way we can do it, we can say 3 tortillas is 15, 3 times 5, 1 red mango is $2, and then 3 toffees is 75 cents. Now one of the hints here is that we have 75 cents. I mean, the only thing that has cents is toffees, so that will be 3 toffees. Right? And then we have 17. How do we get 17? 17 can't be a product of 2 because no multiple of an even number will give us 17. Or 2 times no number can give us 17. So, but we know 15 plus 2 is 17. So we can say, okay, 1 red mango, and we know 3 times 5 is 15. So that will be 3 tortillas. Next, Alyssa bought 2 bonanzas for $9. 3 bonanzas and 2 Oreos cost $17. What is the cost of 1 Oreo? So we can use this information here to determine the price for 1 bonanza. So if 2 is $9, we divide 9 by 2 and we get $4.50. They're asking us about 3 bonanzas, that's part of it. So $4.50 times 3 is $13.50. Right, no, they told us, 3 bonanzas and 2 Oreos. So if we take away the cost of the 3 bonanzas from the total, we will remain with $3.50 for the 2 Oreos. And we divide the $3.50 by 2 to determine the price of 1 Oreo to get $1.75. 42. So when we buy 4 waters, we get 1 free. So in a sense, it comes as if we are getting 5 waters for the price of 4. So 4 sets, we need a total of 20 waters. So if that's how much? 5 sets, or 4 sets of 4 sets of 5, sorry. 4 5s are 20. So 4 sets of the 5 waters will give us the 20. But remember, each set costs $16. So 4 times 16 is 64. If we are given a fraction is equal to an amount, we can flip the fraction and multiply it by the amount to find the total. (12.5% can be written as 1/8. 1/8 of 200 is 25. And C, what is 0.2? 0.2 means 2 over 10, which can be reduced to 1/5. 1/5 of 200 is 40. (44) Gary earned $2,000. He gave his wife quarter of the bonus. His mama third, he kept the rest. How much did he give his wife? So quarter of his bonus, so that's quarter of 2,000 is 500. And then they said he gave his mom a third of the remainder. So we need to find the remainder first. 2,000 minus 500 is 1,500. A third of 1,500 is 500. And then lastly, he kept the rest. So he gave away 5 and 5. So that's 1,000. 2,000 take away 1,000 is 1,000. Ravi bought a cake. He left 3/5 at home. Right, so he remained with 2/5. He ate half of the remainder, so half of the 2/5 is 1/5. He carried the rest to work, which is 2/5 take away 1/5 is 1/5. And they are telling us that 1/5 is equal to a third, because he carried 3, which is 1/5. So when we have a fraction is equal to an amount, we can flip the fraction and multiply it by that amount to find the total. 46. So we can write this like how we write type 2 unequal sharing. Todd got twice as much as Vashti. So Vashti got less, that's box. Todd is twice as much, that's 2 boxes. That's a total of 3 boxes. So Todd is 2 boxes out of the 3 boxes, which is 2/3. (47) So we have a total length of 3.5 to be divided by 7 tables. 7 tables span 3.5, so we divide and we get 0.5 meters or 50 centimeters. 48. 6 street lamps are evenly spaced. So 8 meters is the spacing. If there are 6 street lamps, then there are 5 spaces between them. And how do we get a total distance? Number of spaces multiplied by spacing. 5 times 8 is 40 meters. Hurdles are equally placed, 16 meters, so 16 meters is the spacing. The track is 80 meters long, so the total length is 80 meters. How do we find the number of spaces? That's total length divided by spacing, which is 5. And how many hurdles or objects? 5 plus 1 is 6 hurdles. 50. Spacing is 5 meters. perimeter of a square field. So one side is 100 meters, so 4 sides on the perimeter would be 400 meters. So how many flags? We need to firstly determine the number of spaces, which will be equal to the number of flags for objects in a perimeter. Right, so what is the formula for number of spaces? Total length divided by spacing. 400 divided by 5 is 80. So that's 80 spaces, which is also equal to the 80 flags. 51. A rectangular field has a perimeter, so we know the total length. 30 cones. So this is objects in a perimeter. So the objects is equal to the number of spaces. And they want the spacing. So the spacing is total length over number of spaces. They gave us both items. So we divide to get 2 meters. 52. We have to define the total length. 30 posts, so we have 30 spaces, each spaced 1.5 meter. So the spacing is 1.5 and the spaces is 30. So we multiply them to get the total length or perimeter, which is 45 meters. So here we have unequal sharing. Mark received 12 more than Israel. So Israel got less, so Israel is box. Mark is box plus 12. We add them together. That's 2 boxes plus 12, which is equal to the total that they gave us. So we work backwards. We say, well, we have plus 12 here, so we're going to minus 12. 62 minus 12 is 50. So 2 boxes is equal to 50. So we divide 50 by 2 to get 25. So Israel is 25 and Mark is 25 plus 12, which is 37. So we have 3 girls. We can see that both Katisha and Celicia has an equal amount, which is less than Farida. So they will both be box. Farida will be box plus 3. So we total this together, we get 3 boxes, or 3 times box plus 3, which is equal to 96. So we say 96 take away 3, which is 93. So 3 times some number is 93. So we will divide by 3 to get 31. So Celicia and Katisha is 31 and Farida is 3 more, which is 34. 55. We have what I call type 2 unequal sharing. So 900 in total. His sister got twice as much. So Timmy has box. His sister has twice as much. So that's a total of 3 boxes. Is 900. So we divide by 3 to get 300. So his sister would get twice as much, which is 600. Radha got half as much as Shanice. So instead of working with fractions, we're going to solve this like a type 2 unequal sharing. So Radha got less, so Radha is box. Shanice is twice as much, which is 2 boxes. So notice how we flip this around. We said, well, instead of we putting Radha as half of a box, we just put Shanice as 2 times as much. And look, we still get back Radha being half as much as Shanice. Okay, so that gives us a total of 3 boxes, which is 75. 75 divided by 3 is 25. So Radha is 25 balloons. 57. Esther's both kids is an equal amount, which is less than her. So they will be box plus box And then Esther is box plus box. When we add this up together, we get 4 boxes. So 4 boxes is equal to the total that they gave us. So 28 divided by 4 is 7. So Esther will be 2 boxes, which is 7 plus 7 is 14. Right, so instead of saying the small pack is a third, so instead of using fractions, we're going to use times. So we can also say the large pack is 3 times as much as a small pack. So again, instead of saying the small is a third of the large, we wrote it here as the large is 3 times as much as the small. So we don't have to work with fractions. So this totals 4 boxes, which is equal to 160, the total. So 160 divided by 4 is 40. So the small is 40 and the large is 3 times 40, which is 120. So Brian has the least amount because Jenny got more than Brian and Sarah got more than Brian. So this is Brian's amount. Jenny got 2 more than Brian and Sarah got 4 more than Brian. So let's add them up together. That's 3 boxes, or 3 times box. 2 plus 4 is 6. And all of that is equal to the total that they gave us. So we minus the 6. 54 minus 6 is 48. And then we divide by 3. So that's 16. Brian is 16. Jenny is 18, 2 more. And Sarah is 4 more, which is 20. Table A had 1 less than table B. Table C had 3 more than table B. So table A is the least. Table A, B is 1 more, and then C is even 3 more than B. So put down B's amount here and then add 3. Some persons make the mistake and say, well, okay, C is 3 more than B, so we put on box and we put plus 3. No, that would mean C is 3 more than A, but that's not what they told us. So let's add them up together. 3 boxes plus 1 plus 1 plus 3, that is 5. So 3 boxes plus 5 equal to 107. That was given. So we subtract the 5 to get 102, and then we divide by 3 to get 34. The Arima branch sold 2 less than the Cura branch. The penal branch sold 6 less than the Arima branch. So you have to read this one carefully and take your time. So the penal branch sold the least. Arima branch sold 6 more than the penal branch. And then the Cura branch sold 2 more than the Arima branch. So that's a total of 3 boxes. 6 plus 6 plus 2 is 14. 3 boxes plus 14 is equal to 170. So we minus the 14 to get 156, and we divide by 3 to get 52. And then we can determine the Arima branch, which is actually the Arima branch is supposed to be 2 less, no, it's supposed to be 6 more, so there's a mistake there. 6 more than the penal branch, so let's correct that. So it's supposed to be plus 6. Right, so let me just double check that. Give me a few seconds. So that means we will have 52 plus 58 plus 60. Right, so good. So I just added up the 3 branches amount to make sure we got back 170. Amanda used all of her 200 beads to make 3 pieces of jewelry. Alright, so the hand bracelet has the least amount, so we put that as box. The ankle is 10 more than the hand, and the necklace is a sum. Her necklace uses the same amount as the sum of the hand and ankle. So we add these two together. That's 2 boxes plus 10. So the total would be 4 boxes plus 10 plus 10. So that's 4 boxes plus 20. So we can solve that. We minus 20 to get 180. And then we divide by 4 to get 45. So the necklace will be 2 times 45 plus 10, which will give you 100 beads. Emily has 3 buckets of paint, right? So we want to have an equal share. All right, so I have the explanation here. Emily should combine the paint and then divide the total by 3 to get an equal share for each bucket. So anything that conveys that same message or have that same meaning, you will get it correct. Convert the units. So to go from centimeters to meters, we divide by 100. To go from meters to centimeters, we multiply by 100. Kilometers to meters, we multiply by 1000. Meters to kilometers, we divide by 1000. Liters to milliliters, we multiply by 1000. Kilograms to grams, we multiply by 1000. And grams to kilograms, we divide by 1000. We measure a door in meters, a copybook in centimeters, road in kilometers, the mass of a red bean, grams, 5 bananas, kilograms, a small bottle of water in milliliters, and a large jug of juice in liters. How do we determine the length? We can use this method for all. We can say the end point, which is 7, take away the start point, which is 0. 7 take away 0 is 7 centimeters. We can do that again here. This is 8.1. Each increment represents 0.1 because it's 1 out of 10. So this is 0.1 or 1 out of 10, 0.2, 0.3, 0.4, 0.5, 0.6, 7, 8, 9. Right? So this is 8.1. And this here is 2. So 8.1 take away 2 will give us 6.1. 6.1 centimeters, or 6 centimeters and 1 millimeter. Which path is the shortest from the home to the school? So we were given this one, we can convert it to meters. I'm multiplying by 1000. B, we can add these two together, that's 2400. And C, we can add these together and then convert them. So that's 2.5, which is 2500. So which is the shortest? B. Next. One orange weighs 200, so 5 oranges will be 200 times 5, which is 1000 grams or 1 kg. How many pumpkins do we need to be in this box? So one pumpkin is 500 grams. We need a total of 1000 grams. So 2 pumpkins would give you a total of 1000. So that's one more pumpkin is missing. Next, so we can convert kilograms to grams, and then we can see that this one is heavier. We can also do the same thing. We can convert liters to milliliters, and then we can see that this is heavier. Lastly, for the length, we can convert meters to centimeters to see that this is shorter than this. Next, we will count the cubes. So you have to use your imagination to try to visualize the shape in 3 dimensions. So below this cube here, we will have a cube below it, right? So you have to use that imagination, even though you can't see it. So this is 1 cube on this row, 3 cubes here, 6 cubes here, 10 cubes here. When you add it together, you'll get 20. So that's 20 unit cubes. So 30 students plus 3 students, 30 students plus 3 teachers, 5 parents, so that's a total of 38. And how many maxis do we need? One maxi will hold 15, 2 will hold 30, and 1 more will hold 45. So we need more than 30. So we will use 3 maxis, that will give us 45. So we have 2-seater tables, 3-seater tables, and 4-seater tables. So the 3 2-seater tables will give us 6 seats. The 4 3-seaters will give us 12 seats. So that's a total of 18 so far. We need to seat 42 persons. So we subtract 42 minus 18. So we need 24 more seats. How many 4-seaters do we need? We divide, we get 6. State the time seen in digital notation. So that's easy. That will be 3:30. They didn't tell us if it was AM or PM. B. State the correct time of the clock was 40 minutes fast. So it means that the clock is 40 minutes ahead of the correct time. So we have to go back 40 minutes. So that will give us 10 minutes before 3 or 2:50. So what we can do here is we can subtract. You can see 3:30 take away 40. Since 30 can't take away 40, we borrow from the hour. We bring it across as 60, because each hour is 60 minutes. 60 plus 30 is 90, so that's 90 take away 40 will give us 50. And 2 take away 0 is 2. C. State the correct time of the clock was 35 minutes slow. So if it's slow, we have to add 35 minutes, which will bring us to 4:05. Let's check the working. So 30 plus 35 will give us 65, but we can't write 365. So we have to take away that extra 60 minutes or that extra hour, add it here, that will give us 4, and the remaining 5 minutes we put it here. "73. The clock is 15 minutes slow. What is the correct time?" So we simply add 15 minutes to get 12:35. "The clock is 10 minutes fast. What is the correct time?" We simply subtract 10 minutes to get the correct time. Draw in the hands to show the time. 3:45. So we realize that it's not directly on 3. So as the minute hand makes, let me draw it in. So as the minute hand makes its way around the circle, the hour hand will go closer to the hour that it's going to, or the next hour. So it will go from 3 and will start going towards 4 as it gets closer to 4 o'clock. 2.5 hours, so 2.5 can be written as 2.5, which can be written as an improper fraction of 5/2, and we multiply that by the hours, which is 60, to get 150. And 75 minutes is how many hours? So we divide, we do the opposite. Minutes to hours, we divide by 60. So we get 1, remainder 15. 15 over 60 is the same as a quarter. If we reduce this, we get a quarter. So 75 minutes is really 60 plus 15, which is 1 hour plus a quarter of an hour. Number 77. So we have the start time and the end time, so we can figure out the duration by subtracting. 10:45 take away 8:30. 45 take away 30 is 15. 8 take away 2. 10 take away 8, is 2. 2.25 hours. B. 10:30 plus 11:30 plus 40 is 12:10. We can see the working here, right? 30 plus 40 is 70. So we take away the 60, that 1 hour, we add it to the 11, and the remaining 10, we put it for the minutes. C. We ended at 6, and the activity took 3.5 hours. So we must subtract 3.5. So 0 cannot take away 30, so we borrow. 60 plus 0 is 60. 60 minus 30 is 30. 5 minus 3 is 2. So that's 2:30 p.m. For number 78, when they say any part thereof, if you are paying for any part thereof, it means that if you cross 1 hour going to the other hour, and you only use 15 minutes, you still have to pay for that 15 minutes. So let's say you only spent an hour and a half at the car park, you still have to pay for 2 hours. You pay for the first hour, and the half an hour counts as an hour that you have to pay for. Okay, so let's get into it. So $6 per hour, or any part thereof. So 9:45 to 12:45, that's 3 hours. And then 12:45 to 1:30, that's 45 minutes. So we will check the 45 minutes as 1 hour paid. So that's 4 hours you have to pay for. 4 times 6 is 24. Find the perimeter of each shape. So perimeter is the distance around, or perimeter and area. So the area for this will be, area of a square is side times side, or side squared. 4 4s are 16. The perimeter of a square is side times 4, which is also 16. 4 times 4 is 16. For the rectangle, we know that we need to add all the sides, so 8 plus 5 plus 8 plus 5 for the perimeter. That will give us 26. Or we can say 8 plus 5, length plus width, and then times 2. 13 times 2 is 26. And the area is length times width. 8 5s are 40 meters squared. 80. Determine the area of the grass between the pool and the perimeter fence. So we have the pool area, or rather we have its length and width. So we can determine the length and width of the perimeter fence. So if this is 10, this is given to be 10, we add 4 and 4. So that's 10 plus 4 is 18. And for the width, we have it as 4. So 4 plus 2 plus 2, that's 8. So this is 18 by 8. So we could multiply that to get the entire area. And then we can subtract the area of the pool to get the remaining grass area. 18 by 8 is 144. And 4 by 10 is 40. So 144 minus 40 is 104 meters squared. The perimeter of a square is 24 meters. What is the area of the square? So we can use the perimeter to determine one side. So 24 divided by 4, because we have 4 sides, is 6. So one side is 6 meters. So the area will be 6 times 6, which is 36 meters squared. 82. The length of a rectangle is twice its width. And then we have the perimeter is 42. So let's first determine the length and the width of the rectangle, and then we can determine the area. So we can say length is twice the width, or 2w. Right, we know for perimeter it's 2 length plus 2 width. So we're going to replace this here, this 2 length. We know one of the length is 2w, so 2 of the lengths will be 2 times 2w's, which is 4w. So the length is really 4 width, right? And the width is really, well, the 2 widths is the 2 widths, right? So that's a total of 6 widths. So the perimeter is equal to 6 times the width, which is 42. So the width will be 42 divided by 6, which is 7. And the length is twice as much as the width, which is 7 2s are 14. So now we have the length times the width to find the area. 14 7s are 98. So now we have some statistic questions involving mode, tally and frequency, and even bar. What is the modal shoe? So the answer must be a shoe. So we can see that Puma is the most preferred shoes of all the students. So the answer is Puma. What percent of the students like more than 3 shoes? So we are looking for 4 or more. So that's Daniel. Only Daniel like more than 3 shoes. So that's 1 student out of 5. So that's 1/5 of the students. We multiply by 100 to get 20%. Question 2. What is the modal number of pets? So it must be a number of pets. The answer must be a number of pets. So 2 is a modal because 2 has the most number of students. What percent of the students have less than 3 pets? So that means 2 or less. So it could be 0 pets, 1 pet, or 2 pets. Right? So what percent of the students? That would be these here. So we add them together, 10 plus 15 plus 17, we will get 42. 42 out of the total, let's see how much that will be out of 50, multiply by 100 will give us 84%. Next, we have a dice was rolled a number of times and we see all the numbers that were obtained. So let's just look at one example. Let's look at the number 2. Now how many times are we seeing 2? 1, 2, 3, 4. Let's try it again. 1, 2, 3, 4, 5. So we see the tally here, 1, 2, 3, 4, 5. So that is what we did for all of these here and these here. So we completed a frequency tally chart. How many throws did he make? So we just need to add these together and we get a total, which is 23. What percent of the total hot dogs eaten does the mode represent? So we have to firstly find the mode. Right? What percent of the total hot dogs eaten does the mode represent? So here we have number of hot dogs eaten, right? So what is the modal number of hot dogs eaten? We can see that both Susan and Sally ate 4 hot dogs. So 4 is a modal number, right? Remember, this is not the modal. That is not the mode in this question. Okay, so 4 is a modal number. So what is the total? We add these together. 4 plus 4 is 8. 8 plus 5 is 13. 13 plus 7 is 20. So that's 4 out of, no. What percent of the total hot dogs eaten? Oh, that's 8. 8. Hold on. What percent of the total hot dogs eaten does the mode represent? So the mode, will be 4. Yes, that was correct. 4 out of the 20. So that will be equal to 4 into 4, 1. 4 into 20, 5. Yes. 5 times 100 to change it to percent will give us 20%. Next. So 1 hour represents 4 students. How many more students travel by car than bike or bicycle? So bicycle is 1 and car is 5. So that's 5 minus 1 is 4. 4 times 4 is 16. Next, what fraction of the students travel by maxi? So let's see, we have 2 here for maxis, 5 here, 2 here, and 1 here. So that's a total of 5, 6, 7, 8, 9, 10. So maxis will be 2 out of 10, which is 1/5. C. What percent of students walk to school? So walking is 2. So again, that's 2 out of 10, which is 20%. And last, what is the modal means of transportation? So the most popular means of transportation is car. If there are in total 90 sunny days, how many does one sun represent? So let's count. We have 1 plus 3 plus 1 plus 3 plus 2. That's 6, 7, 8, 9, 10. So that's 10. 10 suns represent 90 days. So 90 divided by 10 is equal to 9. So each sun will represent 9 sunny days. How many sunny days are there in February? So 3 times 9 is 27. See, if there are 31 days in March, how many rainy days are there in March? Right, so we just subtract the sunny days. Well, let's assume that when it's not, we are assuming that if it's not sunny, it's rainy. right? Which is not the best structured question thinking about it now. So 31 days, and in March we have 9 sunny days. 31 take away 9 is 22. Okay, so that brings us to the end of the paper. Thank you for watching. If you have found this video to be helpful, please feel free to contact us for more information about our classes.